Okay, 3.1, exponential functions and their graphs. We're going to continue to graph. We graph all year. We graphed all last year. You'll graph forever. Never goes away. So an exponential function has a variable in the what?
Base.
Exponent. Exponent. A is just a number. So an exponential function has a base of a, and it's denoted f of x equals a to the x. A has to be greater than 0, and a cannot equal 1. Why is a 1 to any power not an exponential function? Anybody? It's just 1, right? That doesn't increase exponentially. It's just 1. It's a constant. Okay, the base of 1 is excluded because it is not an exponential function. It's 1. Doesn't change. Am I good to go?
Yeah.
Okay, you have evaluated a to the x for integers of rationals, so like 4 cubed is 64, you know that, right? And 4 to the 1/2, that means the square root, so it's 2. We've done that before. So if you need to interpret forms of irrational exponents as well, you need a calculator. So if I have 2 to the x, and I say x is negative 3.1, so I have 2, and I touched it, 2 to the negative 3.1, I would need to use my what? Calculator. Okay, if I have 2 to the negative pi, I would need to use my calculator. You all know how to do that, yes?
I think you can do that one on your own.
Just in your head?
Yeah.
Me too. Okay, basically the answers would be about the same because pi is approximately what?
3.14159.
Okay. Remember a negative exponent, it reciprocates it, so it's actually 1 over 2 to the 3.1. Yes? Got to remember those exponent rules. Okay, in the same coordinate plane, use a calculator to graph the functions. 2 to the x, 4 to the x, 8 to the x, 15 to the x. So, where's my calculator? Ooh, computer's thinking hard today.
It turned off.
No, it didn't. It just is thinking hard.
No. What's X?
You don't know. That's why you're going to use a calculator. So you're going to, in y equals, put 2 to the x, 4 to the x, 8 to the x, and 15 to the x. Oops. Okay, did you zoom 6? So 2 to the x. What did I said? 4 to the x.
Yeah.
8 to the x. What was the next one? 15 to the x?
I think my calculator just ended.
Was that it? 2 to the x, 4 to the x, 8 to the x, 15 to the x. Okay, so zoom 6, so we get that standard screen.
Something is wrong.
Was there another one?
I don't know.
I don't know.
There's only 4.
Yep, there was only 4. Okay, I'm going to zoom out some. Just on the origin. What do you know? That didn't work. What do you notice about them?
They're ugly.
What happens as my base gets larger? What happens to the graph?
It gets thinner.
It gets closer to the y-axis, yes? Okay, so I want to see x to like 100. How about that? And I want to see y. I didn't need to see any negative y's, did I? No. So I'm just going to do -1. Oh, I did that wrong. I don't need to see more x's, do I? I need to see more y's. A lot of times you just mess with the screen. Okay, now do you see it better? So the bigger the base, the quicker this is changing, correct? Would that make sense? Because when I put in 1, 2 to the 1 is 2, 4 to the 1 is 4, 8 to the 1 is 8, 15 to the 1 is 15, right? But when I put in 2, 2 to the second is 4, 4 to the second is 16, 8 to the second is 64, but 15 to the second is
225.
225. Is there a big difference between those numbers? Yes. So the bigger the base, the quicker it increases. And that's what you're supposed to get. I want to go back to that real quick. What do you notice, though, about every single one of them?
They all have the same shape.
They all have the same shape. Where are they all crossing the y-axis?
1.
1. Why?
It's the x-intercept.
Not the x-intercept, the y-intercept. But why is 1 the y-intercept? What is
the
any...
x equals 1.
What is anything to the 0 power? 1. So instead of like when we had a parabola and we moved it around, we moved 0, 0, yes? And when we had an absolute value, we moved what? 0, 0. If I had a cubic, I would be moving what? 0, 0. But here, I'm not going to be moving 0, 0. I'm going to be moving 0, 1.
How are you drawing your desktop?
Because I have, that's, remember, you know how like when I touch the screen before I hit something, it moves to the next screen?
Yeah.
That's what I have to draw. It's like an overlay that allows me to draw on it.
I didn't even realize you were doing that until the kids pointed it out.
Oh. You're really observant. Okay, so our vertex or our anchor point or our critical value with an exponential function is 0, 1, isn't it? Are they all increasing?
Yeah.
What's the horizontal asymptote? Can you tell?
0.
It's 0. Is there any exponent I can put into it? Like any exponent I can plug in and get a negative number?
No.
No. I could put a negative in front of the base and get out a negative number, right? And that's the whole reflecting it over the x-axis, because that's what it happens when we put a negative in front of an equation, correct? But I can't put an exponent in and get out a negative number. It doesn't work. I get out a fraction, but I don't get out a negative number. So let's go back to our notes and talk about what is actually happening. Okay, so here is the parent function of an exponential function. Here is all you need to know. A to the x is your parent function. Your domain is all real numbers. You can throw anything you want in there. Doesn't matter. Your range is greater than 0. Why? We just discussed this. There's nothing you can plug in there, right? The y-intercept is 0, 1, because anything to the 0 power is 1. It is increasing. The x-axis is a horizontal asymptote, because there's nothing you can put into an exponent and get 0 either, is there? Nope. And I don't like that I have both of these on there. Increasing and continuously increasing would be the same thing, yes. So do you need to know what this looks like?
Yes.
Yes. So now if I gave you this, you would tell me it is a what? Yes, it is a parabola. What kind of an equation is it? It is a positive. X squared. So that would be a quadratic. Yes? What would you tell me this was?
Square root or absolute.
Absolute value. What would you tell me this was?
Linear.
No. The square root. And what would you tell me this was now?
Linear. I don't know. A parent function.
Exponential.
Miss Nick, I'm never gonna learn your types of lines.
Okay, first of all, Cadence, what is this?
A line.
That is linear.
Is it? No. But aren't those two just the same?
No, what?
Oh. If I flip that one, it would be the same thing.
Oh, the square root and the exponential? I wonder why. Hello, guys.
Wait,
I wonder why.
because they're like this.
To square it, it would.
Yeah.
When I have 4 squared, I have 16. And I have the square root of 16, I have what? 4. Are they inverses of each other? Yes.
Nope.
Well, they're not inverses of each other, but they're kind of. Okay, you guys got this stuff? We're not moving 0, 0. We're moving what? 0, 1. Horizontal asymptote. If I move it up or down, is the horizontal asymptote going to change? Yes. Okay, if I move it left or right, is anything going to change? No, because this is all real numbers, yes? Okay. So, what happened now?
We're decreasing, we're going the opposite
Probably
way.
negative.
Because there is a what? Exponent.
Negative.
Negative exponent. So the other one is the growth. This one is called a decay. My domain is still what? All my real numbers. My range is still what? 0 to infinity. My y-intercept is still what? But now I am decreasing. Everything is the same. So are they actually two different graphs?
Yes, but no.
No. What happens when we put a negative on the x? We reflect it over what axis?
Why?
The y-axis. So the exponential function looked like this. So all we did was reflect it over the y-axis, and now it looks like what? That. Isn't it the same equation?
Yes.
Just reflected. And we're talking about it goes down from left to right.
Really, shut up.
Am I good? You too, am I good? Okay, so transformations. Well, actually, before we start that, we have y equals a to the x, yes? But let's put that into vertex form, guys. So it'd be y equals plus or minus a to the x minus h plus k. What's h do?
Goes left and right,
What's k do?
up and down.
H is always the opposite, yes? If I throw a negative, it reflects over the x, so instead of a growth, it is a decay. Well, no, kind of. Anyway, decay would be the negative, technically the negative. So, are these movements any different than what you've done with quadratic, absolute value, square root so far? No. Okay, so 3 to the x would just be what? 3 to the x. Anything change? No.
What ring?
Okay, so we want the first one to be what? Let's make it this pinky purple thing. So this one's going to be this color. Okay? Well, I know it goes through 1, 0, yes? And if I put in a 1, I would get out a what? 3. So 1, 3. So can I make my line? Probably shouldn't turn that sharp, but you know, it happens.
No.
Okay, so what's the next one happen?
3x plus 1, so we're gonna go.
Okay, what's the next one doing? We're going to do orange.
It's
going left.
one.
It's going left 1 because, so 0, 1 is moving to what?
Zero.
1 over.
How about negative 1, 1?
Yeah.
Yes?
Yeah.
So negative 1, 1. So we're going to go through here.
Negative.
But now we don't have a y-intercept. So we probably should plug a y-intercept in, yes?
Okay.
So the x is 0 on the y-intercept. So if I plug in 0, 0 plus 1 is what? 1. So 3 to the first is 3. So this it should look exactly the same except
1 away.
1 away.
Wait, didn't we say it's supposed to be 1, 3 on the first one too? Yeah. So wouldn't it be down 1 dot?
Oh, yes, it would be down 1 dot. My dot's in the wrong spot. Sorry.
Get it together.
Sorry. I can't erase the other one. Okay. So now what's happening? What color we need to be? Blue?
Blue.
No, we can't be blue. We already got blue. Purple.
No, we already have a purple.
Red.
No, that's pink.
Green.
Green. Okay.
That's not.
It's like a pinky purple. Okay, so what's happening to this one?
It's going
Right
down
to. Oh.
How about left 2?
Yes.
Because the K is an opposite. So if it's going left 2, it's now going to be where? Not left. You said down, and I said left. Okay, if it's going down 2, it's now going to be where? 0.
negative 2.
How about negative 1?
Oh, yes, yes, yes.
Okay, so
It's okay.
0, negative 1 is where I'm going to hit. We need another point. What do you guys want to plug in there?
1.
1. So if you plug in 1, you get 3 to the first, minus 2 is 1. So if you plug in 1, you get 1. So then, if everything goes down 2, my horizontal asymptote went from x equals 0 to x equals what?
3.
Negative 2. So 0 minus 2, Jaden.
Yes.
Okay. So it now goes to here. So do I have to draw it then?
Yeah.
Yep, probably. Okay. Do I have enough to sketch now?
Yeah.
Why sound so different?
What do you mean? Because I went down. Just because I went down. And I evidently can't draw a straight line. So did the rate of change?
No.
No, because that's all 3, isn't it? The rate of change didn't, so I tried to keep about the same increase. I just moved up or down. What would happen if I threw a negative right here?
It goes the opposite way.
It would come here. It would go here. And this would be 1, 2. So 1, 2. It would be here. So this graph would be like that, wouldn't it? So have you done all this stuff before to things? Yes. Now it's just a different shape. And ours are going to look better than all of those. Didn't they? Ours were like amazing. Okay. So you guys can put these on your same graph.
Can you show copy?
No.
Okay.
So you already have the parent function on your graph, correct? And on the last one was this pinky purple weird color. I cannot draw a good curve today. Okay, so now what's happening?
That negative is gonna make it.
Go on the.
This is going to reflect over the x. So instead of going through positive 1, it's going to go through negative 1. And instead of being 1, 3, it's going to be 1, negative 3. And the horizontal asymptote is still 0, but the graph is going to go what? Down. Okay, so that's this one. And the next one reflects it over what? The y-axis. So is the horizontal asymptote going to change this time? No. No. Oh, I forgot to ask you what the range on the pink one is greater than 0, but the range on the blue one is what? Less than 0. Okay. And then this one's going to reflect, so it's still going to go through 0, 1, but it's not going to be 1, 3, it's going to be negative 1, 3. And it's going to go what? Down. There's a pretty good mirror of it, isn't it? My fingers must be pressing hard today. Now, when we had parabolas and reflected over the y-axis, it didn't make any difference, did it? But when I reflect things over the y-axis, is it going to make a difference? Yeah. How do I get it over in this spot over here? How do I get over here? What kind of reflection would I have to do? Wouldn't I have to do both of them?
It would be on that side.
So it would be this dot and this dot, yes? And it would go like that.
Yes.
Do you see that?
Okay.
You see it? Because the blue would be reflected over the x-axis, and then I would take the blue and reflect it over the y-axis. Now I could take the same thing. I could have done the y-axis first and got the orange, and then reflected over the x and got the red. Does it matter which one I do first? No. That's kind of pretty. Questions?
No.
Concerns?
No.
Okay. This is tomorrow's, but I think we just go ahead and start because some of you are going to be gone tomorrow, yes? No?
The art trip.
Anybody? You're going to be gone for the art trip.
I thought I was staying here.
I got to talk to you. You're going to be gone for the art trip. Okay, real quick, we'll just go over this and then we'll stop because my timer is going to go off. Okay, everything tomorrow is the same. It's going to have E. Remember E, that number E on our calculator?
Yeah.
Okay, It is 2.7182818281828182818228. It is called the natural base. Guys, E is just a number. So is it going to change anything about an exponential function? No, it's just the base. It's between 2 and 3, closer to 3. Yes? It's called the natural exponential function. How we remember that is natural things come from the earth. Earth starts with what letter?
E.
E. Is anything going to be different about this? Nope. The y-intercept is still 0, 1. The domain is all reals. The range is greater than 0. It's increasing. What else did I tell you before? Oh, horizontal asymptote is still where?
X-axis.
X-axis, x equals 0. How about y equals 0, not x equals 0? X equals 0 would be a vertical asymptote, wouldn't it? Sorry. Anything different, guys? No. Everything changes exactly like if it was a 3 or a 5 or 6. What is E?
Number.
A number in between 2 and 3, closer to 3. And there's an E button on your calculator. I think it's right above the division.
Yes.
Okay. And everything else we have goes on that. So we can finish notes tomorrow. But that gives you, Jaden, what you need.